Hello my dear students, I welcome you to NEET World. So today we will be discussing one of the most important and that will be very useful and highly important topic for your competitive exams, whatever maybe it will be, like NEET or JEE or whether it may be EAP set for Telangana and AP students. So from this topic definitely there will be at least one question. Okay, so everyone must follow this concept very clearly. So make your notes in a proper way and refer them whenever it is required, and practice a few PYQ questions after completion of this lecture. Okay, let us start our topic here, aromaticity. So this aromaticity is a property of organic compounds. What I am saying, aromaticity is the property of some organic compounds. So those compounds which are aromatic are highly stable. So what I am saying, those compounds which are aromatic are very stable compounds. Okay, so there are aromatic compounds. So how can we identify those are aromatic or whether they are non-aromatic? So how can we identify them and how do we classify them? So let us discuss that from very basic. So first of all, what exactly aromatic compound? Just listen this. Okay, so it is a cyclic conjugated unsaturated molecule or ion. It may be molecule or ion, but it has to be cyclic, conjugated and unsaturated. Unsaturated means it must have some pi bonds in that. Okay, unsaturated molecule or it may be ion. So that is stabilized by pi-electron delocalization. So how that molecule is stabilized? Pi-electron delocalization. Just hold on for this few minutes. So I will be giving complete clarity on these compounds. So how to identify, how to classify them, everything I will be explaining. Just look here, just follow the class. So what is that? First let us take, we know these molecules are what? Benzene molecule. So this is benzene molecule. So here in these, so benzene molecules are the best example for aromatic compounds. Okay, let us start our discussion with benzene first, and I will be moving to other compounds also after discussing about this. Yeah, so first of all look here, these benzene, so these benzene having cyclic structure, yes, these benzenes are cyclic in structure, yes, and having conjugated system, yes, I will tell you again what is conjugated system, and they are unsaturated, yes. So here bond, like pi bond is there now, therefore we can say this benzene is what? Conjugate, I mean this benzene is what? Unsaturated compound, yes. So there should be at least one pi bond between carbon atoms. One sigma bond and one pi bond is there now, at least one pi bond should be there in order to say that as a unsaturated compound, yes. So these are unsaturated compounds, yes. Next, what do we mean by conjugated here? So here this, see pi bond, this pi bond and this pi bond is are at alternate position. See how these pi bonds are located here. So they are positioned alternatively. So pi bond, sigma bond, pi bond. So now what happens is, so this pi bond can shift over here. So when it is shifting here, this pi bond will be shifting here. Okay, so again when it is shifting here, this will be shifting over here. Therefore we will be getting a structure like this. So this is what? This is first resonating structure. So this is second resonating structure, and we discussed about the resonance and how to write these resonating structures in the previous classes. You just go through the playlist if you are not aware of this resonance and how the resonance stabilization takes place. So just refer NEET World channel with name GOC resonance. There will be given everything about resonance and also how to calculate resonance energy. Yes. So now once again look here how the conjugation taking place. The pi bonds are at alternate position. Therefore when this bond is localizing from here to here, when this pi bond is localizing from here to here, so this will be moving from here to here. Yeah. So why this conjugation is happening? Because it should obey this octet rule of these carbons. Now it should have only covalent bonds. How many covalent bonds? 4 covalent bonds should be there around each of this carbon. So covalency should not be exceeded more than the 4, right? 4 bonds. So maximum carbon can form only 4 bonds. That's why it is shifting like this. Yeah, I mean this should be shifted whenever one bond is shifting beside here. Yes, I hope this is clear. So once again look here. So what happening here? This conjugated system means the pi electrons are at conjugative position. When we are saying conjugative, when they are at alternate position. Yes. So here it is shifting here. So when this is shifting onto this carbon, these two carbons, so the already we have one pi bond now, that will be shifting over here, then this will be going here. So when it is shifting, we will be getting a resonating structure like this. The resulting structure from this will be this after shifting of pi electrons. So 1 and 2 are called what? Resonating structures, and the actual structure of the benzene will be looks like this. So there are 6 carbons and the delocalized pi electrons will be shown like this, like a dotted lines here, like a circle. So this dotted circle represents what? It is a pi electron cloud movement within these 6 carbons. So we can call this as resonance hybrid. Yeah, all these things we discussed in the resonance topic. So this is the actual structure of benzene. Now see here. So in benzene, it is cyclic, yes. It is unsaturated, yes. And these pi bonds are shifting, like participating in this delocalization, yes. Yeah. So these are the 3 conditions we have seen. What are the conditions I am saying? Cyclic, planar, yes. All carbons here are sp2 only now. See, each carbon here, each carbon will be having 3 sigma bonds like this and 1 pi bond. So number of sigma bonds are 3, therefore hybridization will become sp2. For each carbon here, the hybridization is what? sp2 hybridization. sp2 hybridization. So we know for sp2 hybridization, the geometry will be trigonal planar. Therefore the complete molecule will be planar in structure. So what is that? It will be planar molecule. So benzene is planar molecule. What is the first conjugation? First condition I told you, compound should be cyclic. The next condition is what? Compound should be planar. So whatever the organic compound we are taking, that should follow these conditions. If it is following these conditions, we can consider the molecule as aromatic compound. Okay. So first condition is compound should be cyclic, and the next condition is compound should be planar. So when it will be planar? So it will be planar when it is having sp2 hybridization or sp hybridization. Yes. The next thing is third one is complete conjugation should be there. Complete conjugation of this pi electrons. Conjugation of pi electrons. Yes. So here see, these are the pi electrons now. So they are completely moving from one side to another side. Complete like circulation and conjugation of electrons taking place now. That is what the complete conjugation of pi electrons should be taking place. The next fourth condition is this molecule should follow 4n plus 2 pi electron rule. 4n plus 2 pi electron rule. So this is what Huckel rule we can say. The fourth condition which we have written here, it is called as Huckel rule. This is what? Huckel rule. Okay. So these are the 4 conditions has to be satisfied by each of the molecule. Then those molecules are considered as aromatic compounds. So here, what is this N here? N can be anything, like it can be 0, 1, 2, 3, so on like this. Okay. So if you place N equals to 0, there we will be getting 2 pi electrons. If you are getting N equals to 1, we will getting 6 pi electrons like that. So what are the aromatic numbers here we are getting for aromatic pi electron numbers? So it can be 2 pi electrons, or it can be, when we put 1 here, it can be 6 pi electrons, or if you put this 2 here, it will be 4 to the 8 plus 2, 10 pi electrons like this, 10 pi electrons like this. We are getting different number of possible 4n plus 2 pi electron rule numbers here. Okay. So you should not confuse what these numbers are. These are coming when we are like taking these n values here. Okay, right. So I will show you some structure, then that will be giving more clarity. Okay. So I will tell you one more thing. What I told you, aromatic compounds are highly stable. Okay. So now let us classify the organic compounds into different formats. So classification of compounds. Okay. We know they can be cyclic, non-cyclic. So aromatic compounds is possible only for cyclic forms. Okay. So aromaticity exists only when it is, first condition here we have written as cyclic form only. Okay. So here in the classification we have 3 types. One is aromatic, and another one is anti-aromatic, and the third one is non-aromatic. So what exactly aromatic, anti-aromatic, non-aromatic? So what are the conditions I told you in order to identify a organic aromatic compound? So it should be, there are 4 conditions I given now. Once again tell me them. Cyclic. Next is planar molecule, it should be planar, SPR, sp2 hybridization should be there. Then next, complete conjugation should be there. Throughout the cyclic ring, complete conjugation should be there. Then next, it should contain this 4n plus 2 pi, 4n plus 2 pi electrons should be there in the given compound. These are the 4 conditions should be satisfied. So when it comes to anti-aromatic, look here, when it comes to anti-aromatic, these 3 conditions are the same. First 3 conditions are same. The last condition is there now, 4n plus 2 pi electron. Instead of having 4n plus 2, here it will be having 4n pi electrons only. How many? 4n pi electrons. It is not like 4n plus 2. Yes. So if it is following these 3 conditions, if it is having 4n plus 2, we can say it is aromatic. Following the first 3 conditions, if it is having only 4n pi, we can say it is anti-aromatic. I hope the things are clear. So it will be more clear when we will be seeing, when we are solving some more questions actually, when we are applying into the some compounds, that will be clear. Just hold on few more minutes. Okay. Then next, what about non-aromatic? The compounds which are neither aromatic nor anti-aromatic, consider as non-aromatic. The compound should not be aromatic or anti-aromatic, then those considered as non-aromatic. Neither compounds neither aromatic nor anti-aromatic, consider as non-aromatic. Okay. So now tell me which can be considered as aromatic, which can be considered as non-aromatic. So I will be showing here. So with a few examples, let us say here I have, here itself we will do, otherwise. So here I just want to take this compound first. Yes, this one. Then next, this one. Yes, tell me out of these 3 which is aromatic. So what are the conditions? Compound should first, it should be cyclic. Yeah. So I am adding one more compound also here. Yes, like this. So is this cyclic? No. Therefore it is not aromatic. Remove this. So it cannot be anti-aromatic also, because for anti-aromatic also it should be cyclic, but it is not cyclic. So it is neither aromatic nor anti-aromatic. So we can say this is non-aromatic. What is this? This is non-aromatic. So what about this compound? So this is cyclic. Yes, first condition is obeyed. But what about second condition? It should be planar. Planar means what is the hybridization should be there? It should either contain sp2 or sp. But all the carbons here given is sp3 only now. All the carbons are having hydrogen like this. All of them are what? sp3 hybridized. sp3 hybridized. So I can say this is also non-planar compound. I can say this is non-aromatic. Non-aromatic. What about this? Yeah, cyclic. Yeah, conjugation is there, but it is only to the partial extent, but not for the complete. So we need to have complete conjugation now. But see, only these 2 are involving in conjugation, but these 2 carbons are having sp3 hybridization. These 2 carbons are having sp3 hybridization. See, these 2 are sp3 hybridized. So these can be considered as non-aromatic. Yes, this is also clear, I hope. Then next come here. All carbons, compound is cyclic. First condition is obeyed. Second condition is compound should be planar. So when, how can we say it is planar? The hybridization of carbon should be either sp or sp2. Yes, all carbons are sp2 here. Just check here. So on each of these carbons there will be one hydrogen. So how many sigma bonds are there? 1, 2, 1, 2, and here out of these 2, one is pi, one is sigma. So consider only sigma for hybridization. Therefore 3 sigma bonds are there. So I can say sp2 hybridized. Yes. So same story applicable for all the carbon atoms. So therefore all the carbons are sp2 hybridized. Yes, it is also clear. Now compound is cyclic, next it is planar, having sp2 hybridization, then next complete conjugation is there or not? Yes, it can shift over here, it can shift over here, and it can be shifting here. So complete conjugation is there. Yes, complete conjugation also present. Next, anything to check? Yeah, fourth condition is what? Huckel rule should be satisfied. Just check whether it is following a Huckel rule or not. Yeah, so Huckel rule for aromatic nature, it should be 4n plus 2 pi electrons. If it is satisfying this number, then we can say it is aromatic. If it is satisfying only 4n pi electron rule, we can say it is anti-aromatic. Okay, just check here how many pi electrons are there. 1, 2, 3, 4, 5, 6 pi electrons are there. 6 means if you place n value as 1, 4 plus 2, 6 pi electrons are there. Therefore, this compound is aromatic. I hope this is clear. Now, let us move in depth. Let us start with few more examples. Let us start with the basic one, the least possible compound, least possible aromatic compound let us take. So, this is cyclic. Yeah. So, now I am writing here one pi bond, and one more here I am writing pi bond with one dot, and one more here I am writing pi bond with positive charge, one more here I am writing pi bond with a negative charge. Yes, tell me, out of these 4 options, which is aromatic, which is non-aromatic, which is anti-aromatic? Yeah, so this is how we can start from the very basic. So these are the least possible aromatic compound. Out of this, there is one aromatic compound. Just try to identify it. Okay, so here this we have, this is sp2 carbon. Yes, 2 sp2 carbons are there, but this carbon is what? sp3 hybridized. sp3 hybridized, therefore it will not involving in conjugation now. So I can say this is non-planar carbon, therefore compound becomes non-planar here because of this carbon. Therefore there is no complete conjugation first, right? Because this carbon will not involve in conjugation. So I can say this is non-aromatic. Non-aromatic. What about this? So all free radicals, remember, all, whatever the species it is, if it is free radical, whatever the compound they are giving, if it is free radical, all free radicals are non-aromatic. Directly you can write this statement, non-aromatic. Okay, and all free radicals are what? Paramagnetic. Paramagnetic. So one more thing you can write. So what I told you, aromatic compounds are highly stable, you have written now. So there you can write aromatic compounds are generally, you can write aromatic compounds are generally diamagnetic. Aromatic compounds are generally diamagnetic. So what is their magnetic moment? They are diamagnetic. And you should have one question that, so why aromatic compounds are stable, sir? Yes, so I will be explaining that also. So these are aromatic compounds are stable because maximum number of the delocalized pi electrons are there na, here delocalized pi electrons are there na, maximum number of delocalized pi electrons are present in bonding molecular orbitals. Where they are present? Bonding molecular orbitals which are lower in energy, So if it is in lower energy, molecule have more stability. See, if something is having low energy means the stability will be more. So all the pi electrons are maximum number of pi electrons present in lower energy bonding molecular orbital, therefore compound becoming more stable. So that's why aromatic compounds are highly stable. And when it comes to anti-aromatic compounds, so generally anti-aromatic compounds are paramagnetic. So how they are? They are paramagnetic. and for them maximum number of unpaired electron, maximum number of pi electrons present in either non-bonding or anti-bonding. So maximum number of pi electrons present in anti-bonding orbitals which are high energy, therefore the stability will be low for anti-aromatic compounds. So that's how you need to understand. Okay, so these points you make a note of these points, and let us discuss about the remaining two compounds here. Okay, so now here this, just look at this. So compound is having all the carbons. We know carbocation hybridization will be sp2. This is double bonded carbon. This is also involved in alkene alkene carbon. So it means they are sp2 hybridized. This is also sp2. So all the three carbons are sp2. Yes. So compound is cyclic. First condition is obeyed. Second condition should be planar. Yes, compound is planar because all of them having sp2 hybridization, right? Okay. Then next thing is, so whether it is having complete conjugation or not. Let us check. So let us delocalize over here. So when it is delocalizing here, this carbon is losing pi electrons, therefore that carbon should get a positive charge. Yes. So shift here, yeah, it is shifted here, and this will be having positive charge now. Now again you can shift this like this. When you are shifting like this, so this carbon is disconnected with the pi electrons, therefore the carbon will be getting positive charge. Yes, write that like this. Done. Then next thing is there any other possibility again? So I can shift now from here to here. So again we are getting the first structure as the above, that is like this. So check here. So 1, 2, 3 and 4. So 1 and 4 are same. So 1 and 4 are same means all the remaining thing are the resonating structures here. So these are the resonating structures which it is showing that complete conjugation is possible, right? So fourth one is, the third one is having cyclic structure, planar, complete conjugation, and now how many pi electrons are there here? So how many pi electrons are there? 4n, n value let us put 0 plus 2 pi electrons. Now check here, 4n plus 2 means 2 pi electrons are there. Yeah. So in the given compound 2 pi electrons are there. So that is a Huckel number na. So the compound is considered as aromatic compound as per the Huckel rule. Yes. So this is aromatic. I hope it is clear how we are identifying aromatic, non-aromatic things. So this is also having cyclic, planar, complete conjugation will be there. Yeah. But it is having, see, negative charge is also considered as pi electrons here, I mean into the counting of pi electrons, because this negative will be become pi when it is participating in the conjugation. See, when it is participating in the conjugation, it is shifting here, the negative charge goes here and create a negative charge here, and here it is a pi bond, right? So how many pi electrons are there totally? 4 pi electrons we should say. So following all the three conditions and having 4 pi electrons, it means 4n pi rule is satisfied. It means it should be anti-aromatic. Anti-aromatic. So this is how we need to solve the questions, or we need to identify which kind of compound it is. I hope it is clear. If you have any doubts, just let me know in the comment box. Okay. Then next, let us move further. So let me take this. Yeah. Identify these compounds first. Cyclobutane, cyclobutadiene. Okay. Let us take this. Cyclobutadiene here I have. Then next I have so these are practice questions you can say. So if you practice this properly, then it will be more clear to you. Yes. So identify which are the following as aromatic, anti-aromatic, non-aromatic. So first one is what? Simply cyclobutane. So there is no pi electrons to discuss about their conjugation, whether they are planar or non-planar. We know by looking at the compound we can say there is no pi electron for conjugation. So directly we can say this is non-aromatic. Aromatic. So what about this? These two carbons are sp3 hybridized. So we can say this is also directly non-aromatic. Now what about this? Yeah. See, all the carbons, so compound is cyclic, all the 4 carbons are having sp2 hybridization and 4 pi electrons are there, so they are in conjugation like this. So complete conjugation is also present, but it is having 4 n pi electrons. So how many pi electrons are there? This is 2, here 2. So total 4 pi electrons are present. Therefore it is like following 4n pi rule, 4n pi electron rule, which means 4 into 1. So this is anti-bond, like anti-aromatic compound now. So this is what? Anti-aromatic compounds. And I told you that anti-aromatic compounds are having paramagnetic nature now. So how can we justify that? So we can take one simple example by following polygon rule. So there is something called polygon rule. So I just wanted to show you how it will be works here. So let me take a circle here. Yeah. So it is not giving. Okay. Let me take light directly. Yeah. Fine. So let us take a rough diagram. Yeah. Consider this as a circle. Now in this you have to arrange this like whatever the polygon we are taking. Like here we have butane now. So it is should be inserted in this by attaching the corners like this. Yeah. So now at each carbon there are 4 carbons now. So at each carbon we have 1 carbon atom. So now just divide this circle into 2 pieces like this we have. Yeah. So now at this each corner, so take the orbitals like this. Okay. So now if this like horizontal line is dividing, if this horizontal line is dividing two, like dividing these orbitals, I can say these carbons, cutting these carbons. So that carbons can be considered as, that orbitals can be considered non-bonding orbitals. So whatever the orbitals present on this line, on that line, so that is non-bonding orbitals. So which are below this is BMO, bonding molecular orbitals, which are above this, above the line are anti-bonding ABMO, we can write in the short form, ABMO orbitals, which lies on the line, so these are non-bonding orbitals. Okay, non-bonding molecular orbitals we can write. So like this we can say. So how many pi electrons we have? 4 pi now. So fill 2 electrons first of all by following the basic electron filling rules. So fill them here first, lower energy first, maximum 2 electrons can be filled, then next higher energy, here one, because we have 4 pi electrons. See, we have 2 unpaired electrons in non-bonding orbitals, therefore I can say the molecule is paramagnetic. This anti-aromatic compound is what? Paramagnetic, and it is having 2 unpaired electrons. So magnetic moment you can calculate based on that using root over n into n plus 2 Bohr-Magneton formula. Yes. Now what about this? Yeah. So here this carbon is having unsaturation, but this is having positive. Yeah, this is also okay. But what about this? This is sp3 hybridized, but we should get sp2 hybridization to have planarity. Therefore the molecule is non-planar, or the carbon is non-planar here. So we can say non-aromatic. Hope this is also clear. Okay. Next, what about this? Yeah, here all the carbons are sp2 hybridized in this molecule, and they are having complete conjugation like this. Check once. Yeah. So when it is shifting here, this carbon should be get positive charge. Again it can shift over here, and this carbon should get positive charge like this. Yeah. Now it can shift over here, this carbon will be getting positive charge like this. Again now you can shift here, if you are shifting here, this carbon will be getting positive charge, and you can write it in this manner. Yeah. So this one and the first one is same, therefore these are the complete conjugation taking like resonating structures where we can see complete conjugation. Yes. So complete compound is cyclic, planar, complete conjugation, and following which rule? It is having 2 pi electrons now. It means 4n plus 2 rule is satisfied here. 2 pi electrons means n value you just take it as 0, 4 into 0, 0. So 2 pi electrons are there. So we can say anti-aromatic. So anti-aromatic. And what about this? Yeah, so it is also having complete conjugation like this. Yeah, so let me take, this is negative charge, no? So when it is negative charge, just take it here and take this to here. Like that, complete conjugation will take place. Therefore, the compound is planar, cyclic, complete conjugation is there. But how many pi electrons are there? Check. This pi bond means 2 pi electrons and negative charge means 2 electrons. Like the 2 negative charges, 6 pi electrons are there in total. Therefore, 6 pi means 4 into 1 plus 2. So, that is also satisfying aromatic Huckel number. Therefore, compound is aromatic. So, this is how you need to identify the compounds. So, one last thing we will take here, the simple one. Yes. So, just do this fast. So, whatever the things we have learned, just apply over here and you will get some clarity. So, out of these two, identify which is aromatic, and the next thing is like this. So, when aromatic compound, like the given species is charged, then we can say that is quasi aromatic. For example, we know this is having 6 pi electrons, compound is cyclic, 6 pi electrons are there, and it can have complete delocalization like this. So, when it is having complete delocalization, it can be planar, complete delocalization, and having 6 pi electrons, which is Huckel number. So, compound is aromatic, and we can say in specifically quasi aromatic compound for this particular one, because it is having charge. Okay. Now, when these quasi aromatic compounds are there, quasi aromatic I am saying. So, these are charged, therefore, these molecules having high dipole moment, they will be having high dipole moment, okay, and they are soluble in polar solvent. What I am saying, they are soluble in polar solvent. And one more thing is, we can say they have high melting and boiling points because of their polar nature, Now, here I just wanted to write, identify what about this thing, and just take this as question number 1 and tell me what is the nature, whether it is aromatic, anti-aromatic or non-aromatic, and tell me in the comment box. Okay. The next thing is, identify out of these two, it is having, see, cyclic, planar, complete conjugation is there, just check here, yes. So, but it is having 4 pi electrons, which means 4 pi electrons means anti-aromatic number. So, therefore, I can say this is anti-aromatic. Okay, what about this? It is having 6 pi electrons, 6 pi electrons are there, following cyclic, planarity and all those things. So, it will be 4 rules are satisfied, 4 points are satisfied, therefore, I can say it is aromatic. If it is not clear, just go to the 4 points which we have written. The first point is cyclic, yes. Next point is planar, yes, all carbons are planar. Next thing is, so planarity, how can we check? So, either they should have either sp2 or sp. Okay. So, there are some exceptions, I will tell you, where sometimes it may be having sp3 also, but they are showing aromatic nature, I will explain that. Okay. The next thing is, yeah, planar, cyclic, next complete conjugation is there, just check like this, yeah, complete conjugation is there like that. Then next 4n plus 2 rule. So, for n value if you put 2, n value equals to 1 if you put, we will be getting 6 pi electrons, yes, molecule is having 6 pi electrons, therefore, it is aromatic, yes. So, this is how we need to identify which is aromatic, which is non-aromatic. Okay. So, now there are some hetero-aromatic compounds, so heterocyclic aromatic compounds. It means there is at least one heteroatom in the given compound. So, this is called furan. What is that? Furan. So, other than carbon, if any, like if the given compound contains any atom other than carbon and hydrogen, we can say that is heteroatom, and the compound is heterocyclic compound here. This is heterocyclic compound as it is containing oxygen. So, the name of this compound is furan, and this is having structure like this. So, it can like these electrons will participate in the conjugation, therefore, it is aromatic. What I am saying, this is aromatic. So, aromatic, furan is aromatic. Similar to this, we have one more called pyrrole. What is this? Name of this compound is pyrrole. Okay, the next thing is we have one more 6-membered ring like this. This is called pyridine. So all these are aromatic only. So just check whether they having 6 pi electrons, complete conjugation, cyclic, everything is satisfied or not. Yes, everything is satisfied, therefore they are aromatic. This is what? Pyrrole. Yeah, pyrrole. Yeah. The next thing is, yeah, so what are the applications we have? So we can also find estimate, like we can find the acidic nature of compounds also. Let me show you one thing. Here I just wanted to give you this compound. Here it is having hydrogens now. Yeah, this compound is given. This compound is given like this, and one more compound is given like this, like this. So just by mentioning some hydrogens like this. Okay, this, let us say this is A and B. Out of these two, which is more acidic nature? Acidic nature if they ask. So how can we do this? Yeah, so acidic nature means, what do we know acidic compound means? It should liberate H plus ion, right? So now let us say if this molecule is acidic and it is releasing one of its proton from here, then this will be having the negative charge, like I am writing as it is, and here I am just mentioning a negative charge here after removing this H plus. So it is releasing H plus ion. Yeah. So now if this is acid, the anion which is obtained from acid is called its conjugate base. Yes. So if the conjugate base is aromatic, then the respective compound is called compound is said to be more acidic. Now we got this one now. So this is the conjugate base which is aromatic. What I am saying, this is aromatic. Therefore the respective acid will be having more acidic nature, respective compound will be having more acidic hydrogen, because the respective compound is more stable than the acid by aromatic nature. That's why it is having acidic proton. Yeah. Now what about this? If we remove one proton, if we release the proton as considering acid, we will be getting we are getting a conjugated system like this, but this is not aromatic, right? So that's why the aromatic compounds are more stable, the conjugate base is more stable than this like this particular system, like normal carbon anion. This is not even a conjugated, normal anion, but this is aromatic compound which is more stable than this, therefore the respective acid will be more acidic. If conjugate base is more stable, respective compound will be more acidic, therefore A is more acidic than B. Okay, and one more thing, let us show you. Yeah, here I am giving like this, and one more is like this, they will mention. So here HA, HB. Now tell me which is more acidic, HA or HB, they may ask, which is having more acidic nature. Yes. So just whatever the discussion we did before, just apply here. So just remove this proton. After releasing the proton, what is the conjugate base we are getting from this? We will be getting a conjugate base like this. From here we will be getting a conjugate base if we remove this proton, we will be getting a conjugate base like this. Yeah. Out of these two, which is stable? Tell me. So it is aromatic, but this is anti-aromatic, right? So since it is aromatic, therefore the conjugate base is more stable, and the respective compound will be more acidic. Therefore I can say HCl is more acidic than HB. So this is how we need to understand the concept. Next thing, sometimes they will be giving you some compounds like this. Like this, let us say this is A and B I am writing. So out of these two, which is having low bond like barrier? Otherwise, tell me, out of these two, which is more aromatic, which is aromatic first? Yeah, if we are looking like this, both looks like non-aromatic only, but if you take the respective anionic forms, like see, actually molecule will not stay like this, it will be like this. Like this, actually it will be in this manner. See, if I shift this double bond, this side, so this will be negative charge, and here it will be having some positive charge, right? So if you consider this molecule, yeah, this carbon anion will be cyclic pentadienyl anion will be aromatic, we know, and this one if you see, this is also aromatic. So both rings are aromatic, therefore compound is stable in this format than this. Okay, so I can say this is aromatic and exist in this format, therefore this will be more stable than this. Okay, and I can say this is aromatic. So due to this reason, instead of having double bond, it will exist with a single bond. So when it is existing with single bond, so I can say it is having low rotational barrier. So what do we mean by rotational barrier? So if there is a compound, here one compound is there, here one compound is there. So if we are able to rotate them like this easily, so I can say they have low rotational barrier. If they are rigid, if they are unable to rotate, so we can say it is having high rotational barrier. See, in the first case, it is having two compounds are same. If I shift this side, two rings are same. If I shift this side, this will become aromatic with a negative charge, but this will become anti-aromatic. Therefore, the bond will not shift anywhere, it will be stays like a pi bond, which is a double bond here. It will not shift anywhere, therefore it will be rotationally restricted. We cannot rotate this. Rotational restricted molecule it is, therefore having more bond rotational barrier in A than this B. So I can say rotational barrier, if they ask, you should say A is having more rotational barrier than B. So like this we have to answer. Okay, so it is based on again aromatic nature only. Okay, I hope this concept is also clear. Now one more thing, yeah, here I have this molecule. See here, these carbons are sp3 hybridized. What is this highlighted carbons? These are sp3 hybridized. Just leave them, just leave these two carbons, just search for other carbons, just look at the other carbons which we have here. Yeah, so I just want to highlight them with the white color, sp3 hybridized. Other than these two, remaining are sp2 hybridized, and they are having some continuous conjugation like this, right? Now check how many pi electrons are there. 1, 2, 3, 4, 5, 6, 7 pi electrons, 7 pi bonds, so 14 pi electrons are there. So 14 pi means which rule it is? 4n plus 2. So n value, if it is 3, so it will be 12 plus 2, 14 pi electron rule is satisfied by this molecule. So just leave these two, so these will not involve in conjugation. Okay, so except that we will, everything is involving, no? So this molecule is also considered as aromatic. Okay, I hope this is clear. Now come to this. So these kind of compounds are called annulenes. What is that? Annulenes. Okay, so now how many carbons are there? Just count them. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Once again, 1, 2, 3, 4. Here we are missing one carbon. Yeah, so we should not miss any of these carbons. So just check once again. At each corner we have one carbon. 1, 2, 3 here, 4, 5, 6. 14. Yeah. So how many carbons are there total? 14 carbons are there now. So you should give it the name as 14 annulene. So write the 14 in a square bracket. So this is a way to represent the compounds. So annulenes are what? Polyenes, conjugated polyenes are called annulenes. So see, these are conjugated system with poly, like multiple number of double bonds, like dienes, multiple number of like enes are there now, alkenes are there now. So that's what like conjugated polyenes are considered as annulenes. Okay. Now these 14 annuline is aromatic or not? They will ask like this. 14 annuline is aromatic or not? Other 18 annuline is aromatic or not? So these kind of questions we will be generally seeing in the exam. So just when they are saying annuline, so just make whatever the number they are saying, na, that many number of carbons should be there with conjugated double bonds. So check whether it is aromatic or not. Now it is having 1, 2, 3, 4, 5, 6, 7. Yeah, 14 pi-electrons are there. Yeah, when we have 14 pi-electrons, that will be aromatic. That will be aromatic. So now even benzene can also be said in the form of annulenes. Now tell me, benzene, what is how can we name it as an annuline form? So see here, benzene is having 6 carbons now. See, this is polycyclic, like polyenes, conjugated polyene, like monocyclic polyene, right? So it should be only single cyclic with multiple like pi bonds in the conjugative position. So I can say there are 6 carbons, 6 annuline I can say. Benzene can be written as 6 annuline. Okay, whether 6 annuline is aromatic or not? Yes, it is aromatic. So I just want to ask you in the comment box, just answer that 8 annuline, 12 annuline, 18 annuline are aromatic or not? Just tell me in the comment box. Okay, then next, yeah. So there is some more questions we will be seeing, like different kind of question. The one more model here it is, which of the following forms precipitate readily with AgNO3. So this kind of question can also be seen on this topic only. So they might give something like this, Cl. Okay, so when it is treated with AgNO3, what happens? The next thing, so I can write AgNO3. So what happens? Okay, yeah. So tell me out of these two. So this will be giving you more clarity. It's enough. Yeah. So if AgCl, like Ag plus Cl minus will be paired up, so we will be getting AgCl precipitate, na? So this is a white color precipitate. Okay. So in order to remove this Cl, see, it should be Ag plus Cl minus. It means the bond should be taken by Cl atom, chlorine atom. Therefore, we will be getting a carbocation. So we will be getting a carbocation. So it means here the remaining piece will be something like this, right? Now from here also, if we remove this Cl minus, the remaining part will be like this, and AgCl precipitate is formed here. So now tell me, out of these two, which is more stable? See, this is aromatic ring now. So this is aromatic ring, which can be possible to form from this, because aromatic, this ring is more stable than this compound, right? Therefore reaction favors forward only, and AgCl precipitate formation readily takes place in reaction 1, and there is no precipitate in reaction 2 because this is anti-aromatic. So if it is anti-aromatic, the compound, the species is unstable, therefore reaction will not favor forward, reaction will not takes place even, because there is no precipitate as it is forming anti-aromatic compound. So only you should answer that only option A will be forming precipitate, whether it is readily, whether it is slowly also, that will be formation only takes place in option A but not in B, because respective compound formed here is anti-aromatic, therefore reaction will not takes place. So this is how you need to answer the questions. I hope this is also very clear. Okay. So if you have any doubts, just ask me in the comment box. Okay. The next thing, yeah. So here I just want to give few questions for you for practice purpose. You just tell me answers for them in the comment box. Yeah. Here I just want to mention few examples for your reference. Yeah. So this is one. This is second one, and the third one is third one. Fourth one. Yes, out of these four, which of the following is aromatic, is or aromatic? So they may ask multiple type question, multiple selective question also, like out of this A, B, C, D, they may ask option 1, A, B are aromatic, B, C are aromatic, or A, B, C are aromatic, like that. They may make it multiple selective also. Okay. In this case, how can we answer? So this is also a different concept here you need to know. So whenever there is small rings like this, which are having angle strain, bond angle strain is there, so that makes the compound non-aromatic. So 1 and 2, option A and option B will become non-aromatic, and this will be having low strain, there will not be much strain as in A and B. Therefore CD, at least if one ring is aromatic, complete compound can be considered as aromatic. So option C and D are aromatic, but not A and B. So this effect is called Mills-Snigson effect. What is that? Mills-Snigson effect. Okay. So option A and B are non-aromatic. Aromatic. These two are non-aromatic, but C and D are aromatic. At least one ring is aromatic now, and there is no strain in this 5-membered ring, but there is heavy strain in 3-membered and 5-membered. So these are non-aromatic. This and this ring are aromatic, therefore overall compounds are aromatic, C and D. I think it is clear. Okay. So option for this is C and D are aromatic. Yes, like this you need to answer. Okay. What about this? See, if one ring is there, we are saying it as benzene. If it is 2 rings, you should say naphthalene. If it is 3 rings, you should say anthracene. Yeah, these are also aromatic compounds. Okay. So now I just want to ask you, compare the aromatic nature of benzene, naphthalene and anthracene. So which is more aromatic? See what I am asking, which compound out of this A, B, C is more aromatic if they ask? A, B, C. So which is more aromatic if they ask? You should answer C is more aromatic than B is more aromatic than A. So when it is, should be answered like this, which of the following is more aromatic? Okay. So this is a different question. Now one more question I am writing. Out of these 3 compounds, if I consider per ring, which compound will be having more aromatic nature? So I am saying, if we take one individual ring, see here multiple 2 rings, here 3 rings are there, na? We need to consider only one ring. So per ring aromatic nature will be more in which case if they ask? So you should go with option A, will be having more aromatic nature. So this is per ring, one ring out of these 2, out of these 3, of this one. So if they ask only per ring aromatic nature, you should go 1, option A, then B, then C. So more is for single ring. So as like cyclic chain or cyclic rings are increasing, aromatic nature per ring will be decreases. That's what you need to understand here. So I hope it's very clear that we discussed most of the things that is required for your exam point of view. So if you are still having any questions or any doubts or any difficulties with this topic, so you just comment, you can write in the comment box. So I will be looking into it and I will be discussing in the upcoming sessions. So our next session will be on GOC part, like including aromatic nature, inductive mesomeric effect and hyperconjugation. All these things we are going to discuss complete, like maximum number of PYQs which can cover from these topics only, and even some chemical reactions without knowing the name of the reaction, we will be going to tackle those questions by using these concepts only. Okay. So for that purpose, I just want to give a conclude question, like a question as a homework for you. So which of the following readily involves in SN1 reaction? So this is a question I have made. For this particular question, we like whatever the knowledge we have based on this aromatic and GOC part, we can able to tackle for this. So first option here I mentioned is Cl, CH2Cl. Yes, so you can answer this kind of questions based on the whatever the knowledge you have. Okay, so for this you just take the question number 3 and tell me answer for this in the comment box. Okay, so remaining things we will be discussing in the upcoming session with the inclusion of PYQs. Okay, so till then if you have any doubts, just tell me in the comment box. Okay, so thank you for watching. Happy learning.